Hello, you're welcome to today's lesson. In this lesson, we are looking at geometry around us as our strand, and the substrand is measurement. And on the measurement, we want to focus on the topic vectors. Now, this is the first part of the video, so we are going to do the intro to vectors. These are your content standard, learning outcome, and the learning indicators. You can pause the video and read through this. Now let's start with the concept of physical quantity. What is physical quantity? You can think through this particular concept. You might have heard it before in your physics class. You can just think through and then come out with something. Now, when we talk about physical quantity in physics, okay, we are saying that it is a physical property of a phenomenon or a body or a substance that can be quantified by measurement. Something you can measure or something that can be quantified. Example can be mass. You can measure your mass. You can measure distance. You can measure time. You can measure speed. You can measure temperature. All these are physical quantities. We can put physical quantities in two different categories. We have what we call vector quantity and scalar quantity, right? But our concentration is going to be more of vector quantity. But let's understand what vector quantity is all about and what scalar quantity is all about. Now, what is vector quantity? What we are saying is that a vector quantity is the quantity that has both magnitude and direction. And so if you take something like force, okay, force, you can apply force to an object. You can quantify the force you apply to the object and the direction that you want the object to move. If you can run to cover a distance in a specific direction, that becomes displacement and it is a vector quantity. And so vector quantity has both magnitude and direction. So any measurement or any phenomenon that you can measure that has both magnitude and direction is considered to be a vector. For example, we have forces, we have displacement, we have velocity, we have acceleration, we have momentum, we have weight. All these have both magnitude and direction. Okay, and so that is vector quantity. Now let's look at scalar quantity. Scalar quantity has magnitude but no direction. Let me give you an example. For this very moment that you started watching this lesson, you spent about 3 minutes. That is the value, that is the quantity, the time you've spent, the magnitude of it. Which direction is this particular time going? No direction. And so we say time is a scalar quantity. If you measure your height, okay, your height, you can quantify the measurement, you can get the magnitude of it, but which direction is your height? Okay, so that also becomes scalar quantity. And so when we pick any physical phenomenon like temperature, we can measure the temperature of your body, the temperature of your room, the temperature of the water. There's no direction to where the temperature is going, and so we say it's a scalar quantity, right? So that is scalar quantity. So we can think of mass, we can think of speed, distance, time, density, temperature, volume, area, and so on and so forth. All these are also considered as scalar quantity. But we are concentrating more on vector, and this time we are looking at vector with distance or magnitude and direction. So more or less we are talking about displacement. Okay, now a vector directed from a point A to point B is denoted by the symbol this. So anytime we want to represent vector, because we're talking about displacement, we're talking about the distance at the same time direction. We move from one point to another and we represent it by the symbol A, B with an arrow on top, where the A is your initial and the B is your terminal respectively. And so if I have a point here and I call it A, and I have a point here and I call it B, and I move from point A to B, okay, I'm moving with a distance at the same time. I'm giving myself a direction, moving from A to B in a specified direction. That is referred to as a vector. And so let's look at this. I have a point O, or my origin, and I'm moving towards the point B. So I can move in some steps, 1, 2, 3, 4, point on the x-axis, and move 1, 2, 3 on the y-axis. It means I have moved distance 4, 3 on x and y axis. That becomes my vector, and that can be represented by OB. That means I'm at O and I'm moving towards B. We can use small letter b to represent a vector. Normally we call it position vectors. For now, we'll call it position vector. We'll learn more about that in our subsequent videos. And so if I start from O, that's the origin, to A, then I can represent that by a small letter A. That means the person started from O and is moving towards A. O is your initial, A becomes your terminal as well. Again, if someone starts from O and move towards M, O is the initial, M is the terminal, and we can use small letter m to represent that. Right, so this is the intro aspect of vectors. In our next lesson, we are going to dive deep to look at how we can represent vectors in 4 different modes. I'm sure this has been a wonderful lesson for you. Watch out for the next video. Thanks so much for watching.